On these long quarantine days, have you ever asked yourself, what is light? Light is more than just turning on a lamp. Light is also a form of energy called radiation that stars like our sun emits. Most of what we know about the universe we have learned from analyzing light that reaches us from distant stars and galaxies. We see light by detecting color, but this is just a sampling of all radiation, and even though we can't see it, it's still real. When you listen to the radio, the music is being broadcasted by a type of electromagnetic radiation called radio waves. If you have an X-ray taken, the machine is using another type of electromagnetic radiation called X-rays to produce an image of your bones. And as you watch this video, your eyes are gathering visible light. These forms of energy travel in waves, like the waves of an ocean, except that ocean waves need water and electromagnetic waves can travel through empty space. The length of these waves will determine the characteristics and can be arranged on the electromagnetic spectrum. This is the electromagnetic spectrum. As you can see, the visible light, the colors that appear on the rainbow, are just a small part of the spectrum. The right side is going to have longer waves than the left side. Blue is on the side with the shorter waves, and red is on the side with the longer waves. The shorthand to remember this is shorter is blue, longer is red. Radio waves are the longest type of electromagnetic waves, and gamma rays are the shortest. When light waves are bent, this is called refraction. As you'll see, the red waves, which are longer, are refracted less than the shorter waves, the blue ones, which will actually bend. A great example of this that we learned in this class are lunar eclipses. When the moon moves in the shadow of the Earth, it blocks the sun's rays. The longer wavelengths, closer to red, are going to be straight and hit the moon on the other side of the Earth, as opposed to the shorter wavelengths like blue are going to be bent and not reach the moon. And this is why during a lunar eclipse the moon appears red in the sky. Astronomers use a tool called a spectroscope to separate starlight into color, and they use the spectrum to learn more about stars. There are three types of visible spectrums that scientists used to tell which objects in space they're seeing. The first is called a continuous spectrum, which is what you see here, an unbroken band of colors, which you're probably familiar with. This spectrum is emitted by hot and dense objects, like a light bulb. The second type is an emission spectrum, unevenly spaced lines of different colors. This spectrum comes from different elements. Each element will emit different colors, so we can determine which gas it is. Take a look at this clip from a demonstration which shows a continuous spectrum and the different emission spectrums from different elements.
You'll see, as you look on the right side, violet through all the colors of the spectrum all the way through red. So that's a continuous spectrum. And what you see in this case are a green line and a blue line predominantly in this mercury spectrum. You'll see three lines. The farthest from the central image is a red line. That's the hydrogen.
And finally, the third type is an absorption spectrum, a continuous spectrum crossed with dark lines. This is caused when light passes through cooler gases, which absorb some of the wavelengths. An example of this is our sun. Our sun's interior is hot and dense, emitting a continuous spectrum. As the electromagnetic waves pass through the sun's cooler outer layers, some of these waves are absorbed, resulting in an absorption spectrum. By seeing which lines are there, we can tell which elements are present in the sun based on the emission spectrum. Now, electromagnetic waves also tell us how things move in relation to Earth. Let's look at an example. When a fire truck passes you with its siren blaring, you notice how the sound changes as it approaches you and moves away. This is because as the fire truck approaches you, the sound waves become shorter, causing the pitch to get higher. As it moves away, the wavelength increases, causing the pitch to drop. This applies to light as well. This is called the Doppler effect. As a star approaches Earth, the wavelength that it emits will become shorter. We know that shorter is blue, so it's going to shift towards the blue end, called a blue shift. As it moves away from Earth, the wavelength is going to increase. We know that red is longer, so it's going to shift the wave towards the red end, called a redshift. That's all you need to know for today. Tomorrow we're going to talk about the stars. Please make sure to answer the questions in the form below correctly. If you have any questions, please send it to me in the Google Classroom and see me on Zoom. Thank you so much for watching. Have a great day.